Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today we are going to go over an example of rotation. A solid disk of radius 0.1 meter is mounted on a vertical axis. A string of negligible mass is wrapped around the rim of the disk, passes over a small lightweight frictionless pulley as shown, and is tied to a block of mass 0.05 kilograms. The system is released from rest, and the computer records the velocity of the floating block as a function of time, as shown below. Part A. Use the graph, calculate the acceleration of the floating block. So the graph we're given is velocity versus time graph. In velocity versus time graph, the slope is acceleration. So in order to find acceleration, we just have to find slope. To find the slope, you need to draw a best fit line, and this best fit line should be closest to all the points. You should also have some points like above and some points below, kind of like in the middle. It does not have to pass all the points, it doesn't have to pass any points, but the key is to be closest to all the points and have some above and some below. Acceleration equals to slope. Slope, you need to choose 2 points. So these are the 2 points I chose because it's easy for me to read those points. One is 1.25 in the y direction, the other one is 1.125 in the y direction, and their corresponding x direction. This is the acceleration I have. So it depends on the graph. Your number can be a little different from mine, and that is okay. Part B. Use the result from part A, that's we know the acceleration. You need to calculate rotational inertia of the disk. How do we find rotational inertia of the disk? Let's see, we know the acceleration, we know this mass, right? We know the radius of the disk. So we need to go back to Newton's second law. For block, the translational Newton's second law is sum of the force equals to ma. Sum of the force on the block is gravity and the tension. So the difference between the two equals to ma. Again, down as positive because that's where the block is accelerating. Then for the disk, we have sum of the torque equals to I alpha. And what is the one producing the torque? That's tension. T times R equals I times alpha. Alpha equals A over R because the disk is rotating without slipping. We have 2 equations and 2 variables. The 2 variables are t, we don't know, and I, we don't know. So in order to solve for I, we solve for t from the top equation, substitute that value into the second equation, t equals m, g minus a. Then we substitute that into t and solve for I. So I equals m, g minus a times r squared divided by a. Substitute all the numbers. This is mass. G is 9.8 acceleration. I use what I got, 2.5. 0.1 is R squared divided by A again. So the value I have is 1.46 times 10 to the negative 3 kilograms times meter squared. Again, your number can be a little different because the value of A can be different from mine. That's okay. Part C. Calculate angular momentum of the disk at time t equals to 0.45 seconds. Angular momentum equals I times omega. Because this is constant acceleration, because the force is constant, and so is the torque. So omega equals omega naught plus alpha t. This is going from rest. So the system is released from rest, so omega naught equals to 0. L, angular momentum, is just I times alpha times t. Alpha equals A over R. We know A is 2.5, R is 0.1, T is 0.45, and we found I from part B. Substitute all the numbers, and L equals 1.64 times 10 to negative 2 kilograms times meter squared over second. Make sure you have your units for every single answer. Again, your number can be a little bit different because acceleration can be different. Your I would be different. Last part, The disk is removed and replaced with a hoop of the same mass and radius, but with all of its mass concentrated near the rim of the hoop and connected to the axis by a lightweight spokes. The experiment is then repeated. Is the angular acceleration of the hoop greater than, less than, or the same as that of solid disk? Justify your answer. So what's the difference between a hoop and solid disk? Hoop has greater moment of inertia. So moment of inertia is like a mass. So the mass you have, the more mass you have, the less acceleration you have with the same force. It's the same thing. The more moment of inertia you have, it's harder to turn it. So as a result, the angular acceleration of the hoop is less than that of the solid disk because the hoop has greater moment of inertia. And because the force, this block is the same in both cases, the force remains the same, so the acceleration will decrease. That's it for today. Thanks for watching. See you next time.